gently beneath a blanket of stars. Tonight, we're drifting into one of the most powerful and perplexing mysteries in the known universe. A place where light disappears, time folds, and the laws of physics begin to whisper strange and ancient secrets. We're talking about black holes. Not the kind you might imagine in cartoons, vacuuming up galaxies like cosmic Roombas. Though, honestly, that image isn't entirely wrong. Black holes are real. They exist, and they're unlike anything else we've ever discovered. Some scientists call them one-way doors to the unknown. Others suggest they might be the engines of reality itself, or the delete key on the universe's keyboard. Tonight we won't shout these questions into the void. We'll whisper them. What is a black hole? Where do they lead? And is it even remotely possible that they could one day erase everything we know? But before we fall too deep into the gravitational pull of that idea, let me ask, where are you tonight? What time is it where you are? Maybe it's early, maybe it's late. Maybe you're lying in bed with one foot tangled in the covers, listening to the hum of your own breathing. Maybe you're just hoping sleep will find you soon. If this little voyage into wonder feels like the right kind of quiet, I'd be ever so grateful if you gave it a like or subscribed, or even shared it with someone who might need a soft place to land tonight. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll be lying in the dark thinking about the strange beauty of collapsing stars. So settle in, slow your thoughts, and let's begin. Because somewhere beyond the edge of light, between the silence of space and the flicker of thought, lies the shadowy secret of black holes. We've all felt it, haven't we? That peculiar pull, that strange sensation of something vast brushing against the edge of our thoughts. A quiet awe, a subtle shiver, a sense that somewhere out there, far beyond the moon and weather and headlines, lies something watching, not with eyes, not with intention, just existing, immense, unbothered, silent. Black holes have that effect on us. They don't rise in our sky or shape our seasons, and yet they stir something primal, the way deep water does, or the dark woods at night. We know they're out there, swallowing stars and bending time, and yet our minds keep asking, how? Why? What's inside? What happens next? Sometimes, when you hear the phrase black hole, it's not about astronomy at all, it's emotional. I'm stuck in a black hole, someone might say. Everything just disappears. It's the metaphor we reach for when something feels endless, inescapable, or crushing. A breakup, a loss, a bout of insomnia that stretches on like it might never end. And that's telling, because black holes aren't just scientific puzzles, they've become emotional shorthand for our deepest human fears. Oblivion, isolation, the fear that we too could vanish and leave no trace. But they also carry a strange comfort, a dark beauty. Like the ocean at midnight, they remind us there are things far older, deeper, and more powerful than we are. And for some, that's not terrifying. It's calming, humbling, even soothing. Have you ever looked up at the night sky, really looked, and felt your thoughts slow down, as if your worries, your to-do list, even your name started to feel small? Not insignificant, but simple, manageable, like whatever you were carrying could finally be set down for a moment, under the weight of 1,000 quiet stars. That feeling, that hush, is part of what black holes do to us. They're reminders of scale, not just physical, but temporal, because a black hole doesn't rush, it waits, patiently, silently. It could take millions of years to pull something in, to erase a star's memory, and yet once it does, there's no coming back. No light, no map, no echo. And here's the twist. We don't actually see black holes. Not directly. They have no surface, no colour, no outline. What we see when we look at them is their absence. The way they warp the light around them. The way stars dance nervously near their edges like moths circling a silent flame. Imagine that. Something so powerful it defines itself by what it removes. It's a strange mirror for how we experience certain moments in our own lives. There are events, heartbreaks, disappearances, decisions that we don't remember by what they were, but by what they took. The empty chair at the table, the silence after the call, the weight of what isn't there anymore. And yet, we keep circling the idea, just like stars. Even in fiction, black holes pull us in. They're everywhere, in stories, in dreams, in films that twist space and time into loops and paradoxes. Not just because they're dramatic, but because they represent a question we can't stop asking. What happens if I go beyond the known? That's the gravity at work. Not just in space, but in the mind. And when we think about them, late at night, eyes open in the dark, we're not really thinking about astrophysics. We're thinking about thresholds, limits, the edge of understanding, the end of the road, and what, if anything, might lie beyond it. Have you ever had a dream where you were falling? Not a nightmare, not a panic, just a slow, endless drift downward with no impact, no bottom, only motion. Black holes feel like that. At least the idea of them does. Not something hunting us, but something pulling softly, patiently, asking, do you want to know what happens next? It's no surprise then that the term event horizon feels so mysterious. It sounds like poetry, but it's science. The event horizon is the boundary of a black hole, the point of no return. Cross it, and not even light can escape. And doesn't that feel familiar? We've all had our own versions of event horizons, moments we crossed without realizing it, until we looked back and found the past unreachable. A final goodbye, a choice we can't undo, a moment that, in its quiet way, changed everything. The gravity didn't feel strong until it was too late to turn around. This is how black holes live in our minds, not just as collapsed stars, but as metaphors for emotional tipping points, for the limits of memory, for the places in our lives that resist explanation. But it's not all loss and silence. Some thinkers believe black holes might not be the end, but a door, a portal, a rebirth. And that's just as human a hope. The idea that nothing is ever truly gone, only transformed. That even at the center of darkness there might be something new. And what about time? That old trickster slips in here too, because near a black hole time doesn't behave. It bends, slows, distorts. From far away it looks like you're moving in slow motion. To someone falling in it feels like everything else is speeding up. It's a strange paradox, time stretching and shrinking at the same moment, depending on your point of view. Which, again, feels oddly familiar. Have you ever had a moment so intense, so emotional or surreal, that time seemed to stop, or speed up, or collapse into a blur you can't quite put in order? Your first kiss, a loss, a narrow escape, a dream. That's what black holes teach us in a way, not just about physics but about perspective, that time and space and even reality itself might be less fixed than we think, that how we feel and where we stand shapes what we understand. And isn't that a little comforting too? To know that even in the cold, indifferent stretches of the cosmos, reality still makes room for subjectivity. That a black hole, no matter how alien, still reminds us of us. Our fears, our wonder, our longing to know what lies just beyond the next horizon. So maybe that's why they haunt us. Not because they're terrifying, but because they reflect the deepest parts of being human. Our curiosity, our grief, our awe, our stubborn refusal to stop asking questions, even when the answers are cloaked in shadow. We can't see them, but we feel their pull, not just out there, in here too. Long before telescopes scanned the sky and equations danced across chalkboards, there were stories. Humans have always looked up, always wondered, always told each other tales to make sense of the stars. We didn't call them black holes, of course. We didn't know their names or their nature, but we sensed them in dreams, in dread, in the dark places of the cosmos where light seemed to vanish and never return. Because even before we knew what we were looking at, we understood something about the void. We knew that the sky, for all its beauty, was hiding things, and so we named those shadows with our myths. The ancient Egyptians believed that each night the sun god Ra sailed through the underworld, a vast and dangerous realm called Duat. There, he would confront the serpent Apep, a monstrous force of chaos that tried to devour the sun and plunge creation into eternal darkness. Some scholars think of Apep as a kind of mythic black hole, a devourer, a darkness so vast it threatened reality itself. But Ra always emerged victorious, and so the sun rose again. In Hindu cosmology, the universe is constantly created, destroyed, and reborn in cycles. The god Shiva dances at the end of time, dissolving the cosmos so it can be remade. Some of these stories speak of cosmic voids, moments between creation and destruction, where everything collapses into nothingness. It echoes eerily with modern ideas of gravitational collapse, of matter imploding into singularity, waiting for the next breath of time. The Norse told of Ginnunga Gap, the yawning void, a primal nothingness that existed before the worlds were formed and perhaps after they fall. When Ragnarok comes, when the gods fall and fire consumes the branches of Yggdrasil, all things will dissolve into that gap once more, a kind of cosmic reset, an erasure not unlike the hypothetical fate black holes may bring, the information paradox, the slow fade into heat death or worse, deletion. In many indigenous traditions, the sky is not just a space but a living memory. The Navajo see the Milky Way as a pathway, a shimmering bridge of spirit and story. In some Andean cosmologies, dark patches in the night sky, where no stars seem to shine, are not empty at all. They are constellations of shadow, animals and beings woven from absence, not light. What Western astronomy calls dark clouds in the Milky Way, these cultures see as cosmic forms full of meaning. The llama, the fox, the serpent, black shapes in the sky, more vivid than the stars themselves. And isn't that exactly what a black hole is? A shape made of shadow, a presence carved out of disappearance. For centuries cultures spoke of underworlds, realms beneath or beyond, where souls travelled, where light failed, where time lost its way. Greek mythology gave us Tartarus, a deep abyss used to imprison the most ancient forces. It lay beneath Hades, darker, deeper, more eternal. In one version of the myth, it was so far below the surface that if you dropped an anvil, it would take 9 days to reach the bottom. That image of a fall with no end sounds strangely like what happens at the event horizon. Once you cross, there's no return. The fall becomes eternal. Time itself begins to stretch, warp, whisper. And yet, for most of human history, we had no name for this. We saw only hints. In the 18th century, as telescopes improved and Newton's laws began to reshape how we saw the universe, some thinkers began to toy with a strange idea. What if there were stars so massive their gravity could trap even light? A British philosopher named John Michell wrote a letter in 1783 proposing just that, a dark star whose escape velocity exceeded the speed of light. He had no way to prove it, no math to follow it. But the idea was there, a whisper before the shout. Still, the term black hole wouldn't arrive until the 20th century, and even then, only after we'd entered a new era of cosmic imagination. In 1915, Albert Einstein published his theory of general relativity, showing that gravity isn't just a force, it's a warping of space and time itself. Suddenly the universe became bendable, soft, dynamic, and lurking in Einstein's equations was something strange, a possibility, a kind of singularity. It was Karl Schwarzschild, a German physicist and soldier serving on the Russian front during World War I, who first solved Einstein's field equations and found a solution describing a collapsed object. something with a boundary, now known as the event horizon, beyond which no information could escape. He died of illness soon after, but his math lived on, waiting for the rest of the world to catch up. Still, even Einstein himself doubted that such things could really exist. They seemed like mathematical curiosities, too extreme, too absolute. Nature, he thought, surely had better taste, but nature, as it often does, had other plans. By the mid-20th century, scientists like J. Robert Oppenheimer and John Wheeler began to seriously consider what would happen when a massive star ran out of fuel. With nothing left to support its weight, it would collapse under its own gravity, shrinking, compressing, falling inward until even light was trapped. Wheeler is the one who gave this idea its name, the black hole. He meant it quite literally. Not a metaphor, not a shadow, but a region of space with no escape, no surface, no return. But language has a funny way of carrying echoes, because even now, decades later, black hole still feels like more than physics. It feels like myth, like metaphor, like something ancient that found new clothes in the light of science. And around the world, cultures began to absorb the idea. In popular media, black holes became symbols of danger. The villainous portals in space operas, the swirling maws in animated films, the thing that eats the ship if you veer too far off course. But they also became something more subtle, a symbol for the unknowable, the ineffable, the edge of science and spirituality where understanding dissolves into silence. In modern literature and film, the black hole is often portrayed not just as a physical threat, but as a philosophical one. In Interstellar, a black hole named Gargantua bends time so dramatically that minutes near its surface become years far away. In Contact, it's the place where memory, science, and faith blur together. In Dreams, it becomes the symbol for emotions we cannot name: longing, grief, wonder. And through it all, we continue to ask the same questions, just in different languages. In Japanese, the term for black hole is brakuhoru, a transliteration. But in poetry and art, it often becomes a void where memory lives. In Arabic, thukb aswad, carries an air of mystery, like a tear in the fabric of the world. In Spanish, agujero negro, like a hole in the soul of the cosmos. Some languages speak of them not as holes, but as eyes, the eye of the void, the pupil of the night, a place that looks back. And perhaps, in a way, it does. Because the more we study black holes, the more they reflect us, our curiosity, our limits, our fear of forgetting, our hunger to understand. They're the final stop on the line between science and story, where Newton hands the baton to Nietzsche and telescopes meet dreams. Even now, in classrooms and observatories, scientists wrestle with their mysteries. We measure their spin, map their shadows, debate their paradoxes, but we still describe them in human terms. We say they have appetites. We talk about them eating stars. We imagine them as traps, or monsters, or gateways. Because that's what we do. We tell stories around the campfire, even when the fire is a dying star, and the stories don't all agree. Some say black holes are the end, the universe's final eraser. Others say they might be the seeds of new beginnings. Some theories suggest that every black hole could birth a new universe inside, like a Russian doll of realities. Others propose that information isn't destroyed at all, just scrambled beyond recognition, waiting, somehow, to be recovered. In Hindu thought, destruction is not a bad thing, it is part of a cycle. In Buddhist cosmology, there are vast kalpas, cosmic timescales so long they make black hole lifespans seem short. The death of a star is not the death of all things, it is transition, transformation. Even in the Torah and the Bible you find whispers, phrases like the deep, the void, the darkness upon the face of the waters. Language meant to grapple with things that cannot be seen, only felt. And in our modern myths, the language of comics, cinema, and speculative fiction, black holes become metaphors for rebirth, resurrection, time travel, infinite memory. They are wombs as well as tombs, labyrinths as well as prisons. We still don't know what lies inside them. Not really. We know the math, we know the theories, but no human, no probe, no particle, no photon has ever returned from inside an event horizon. It is the ultimate silence, and yet, across history and culture, that silence has always spoken to us. In drums, in dreams, in symbols carved into stone, and tonight it speaks still, in the hush between your breaths, in the dark just beyond your window, in the space between stars where something vast and unseen is waiting, not to harm, not to hunt, just to be. And so we keep watching, keep wondering, keep telling stories, in data, in myth, in whispers, because even if we never fully understand them, black holes remind us of something essential, that the universe, in all its brilliance, still contains shadows, and that even in those shadows there is meaning. Let's drift now from myth into method, from metaphor into mathematics. Though don't worry, we're not in a hurry. We'll unfold it gently, like a blanket warmed by thought. To understand black holes, we begin not with darkness, but with gravity. Gravity isn't just what holds your cup to the table, or keeps your feet on the floor. It's the quiet sculptor of the universe. It gathers gas into stars, stars into galaxies, galaxies into the vast threads and filaments of the cosmic web. Without it, there'd be no structure at all, just particles drifting forever, never touching. But gravity isn't only a force, at least not anymore. In 1915, Albert Einstein changed everything. He proposed that gravity isn't something that pulls, but something that bends. According to his general theory of relativity, mass tells space how to curve, and space tells objects how to move. Picture a stretched sheet of fabric. Place a bowling ball on it, and the sheet dips. That's what mass does to space. Now roll a marble nearby. It curves inward, not because it was pulled, but because it followed the shape of the sheet. Gravity, in Einstein's view, is geometry, and black holes are the most extreme geometry we've ever imagined. When a massive star runs out of nuclear fuel, that steady fire in its heart that pushes outward, gravity takes over. With no more pressure to fight back, the star collapses inward. Its core squeezes tighter and tighter until, in some cases, it passes a point of no return. The matter becomes so dense, so compact, that it warps space-time into a pit no light can climb out of. That's a black hole. Not a thing, really. Not an object, but a region of space, curved so intensely that it disconnects from the rest of the universe. At the heart of this invisible region is something called a singularity, a place, or perhaps a state, where density becomes infinite, where our equations break down. It's not just that we don't know what happens there, it's that our current physics can't know. The math divides by zero. Time and space twist into a knot too tight to untangle. Surrounding this singularity is the event horizon, the border, the edge. From outside you can orbit a black hole, shine a light at it, throw pebbles into it. But once anything crosses that invisible threshold, light, matter, even information, it cannot escape. It's gone, at least as far as we can tell. For decades, we weren't even sure black holes really existed. They made sense in the math, but were they just theoretical artifacts, or actual entities lurking in the night sky? The answer came from the stars themselves. Astronomers began to notice strange things. Pairs of stars where one was invisible, but its companion star was orbiting something hard, fast. Sometimes, matter from the visible star would spiral toward its unseen partner, heating up as it fell, glowing in X-rays. Too small to be a cluster, too heavy to be empty space. The invisible object had to be incredibly massive and incredibly compact. A black hole. One of the first strong candidates was discovered in the 1960s. Cygnus X1, a mysterious X-ray source in the constellation Cygnus, eventually confirmed as a stellar mass black hole, formed most likely from the collapse of a massive star. But Cygnus was just the beginning. Over time we found more, some just a few times the mass of our Sun, others hundreds, even thousands. And then came the real giants, not lurking in distant star systems, but resting at the centres of galaxies. Supermassive black holes, millions, even billions of times the mass of the Sun. Quiet, patient monsters around which entire galaxies whirl. The one at the heart of our own Milky Way is called Sagittarius A, a compact object over 4 million times heavier than our star, and it's not just sitting there, it's spinning, feeding, burping jets of radiation into space, slowly, invisibly shaping the galaxy we call home. But if we can't see black holes, how do we know they're there? We know because of what they do to the world around them. When matter falls toward a black hole, it doesn't just vanish quietly. It heats up, forming a swirling disk, called an accretion disk, where particles crash into one another at near-light speeds. These disks can glow brighter than entire galaxies. Some shoot out jets, beams of plasma that stretch across light years. In 2019, a global collaboration of scientists, using a network of radio telescopes called the Event Horizon Telescope, captured the first image of a black hole's shadow. Not the black hole itself, remember, that's invisible, but the glowing halo of hot gas spiraling around it, bent by gravity into a ring of fire. It was breathtaking, a bright orange circle, blurry at the edges, with darkness in the centre, the absence of light. A literal silhouette of the void. That shadow revealed the black hole at the heart of the galaxy M87, 55 million light-years away. A supermassive giant 6.5 billion times the mass of the Sun. And for the first time, we saw the invisible. Not through metaphor, but through measurement. It was one of the most poetic moments in scientific history. An ancient myth finally meeting its modern mirror. But black holes aren't just cosmic curiosities. They warp the rules. Time, for instance, behaves very strangely near them. According to relativity, the stronger the gravity, the slower time moves. Near a black hole, time slows dramatically. A clock orbiting close to the event horizon ticks slower than one far away. From your point of view, you're moving normally. But to an observer farther out, you appear to be moving in slow motion. If you fell into a black hole, and let's hope you don't, the experience would be strange indeed. From your perspective, you'd fall freely, quickly, crossing the event horizon in a moment. But to someone watching from a distance, you'd seem to slow down, hover, freeze just outside the horizon, forever redshifting into darkness. It's as if time itself breaks in two. Fast for you, slow for the rest of the universe, and then nothing. From the outside, you vanish. From the inside, no one knows. Do you hit the singularity? Are you stretched into spaghetti by tidal forces? What physicists affectionately call spaghettification? Or do you go somewhere else? Some theories suggest the singularity is a kind of bridge, a passage to another region of space, or another universe entirely. A wormhole, a tunnel, a doorway. Others say no. It's an ending, a final punctuation mark where matter, time, and knowledge all collapse. And here's where the science gets stranger still. Because for a long time, physicists believe that anything that falls into a black hole is lost forever. Not just physically, but informationally. That means the data describing its structure, its properties, even its history, gone. But that idea clashes with a fundamental rule of quantum physics. Information cannot be destroyed. Even when you burn a book, the information isn't gone. It's scrambled in the ash, the smoke, the photons. In principle, it's recoverable. But black holes delete. Or do they? This is the black hole information paradox, one of the most important puzzles in modern physics. And like all great questions, it's still unresolved. Some scientists believe that the information is encoded on the event horizon itself, like a cosmic hard drive. Others think that as black holes evaporate, a process predicted by Stephen Hawking, where black holes slowly emit radiation over time, the information leaks out subtly, mysteriously, and some say we're still missing a piece. A new physics waiting in the wings, a theory of quantum gravity that will unite the geometry of space-time with the probabilistic haze of quantum mechanics. Because as it stands, general relativity and quantum theory, our two best models of reality, don't play nicely near black holes. One curves the universe, the other quantizes it, and at the singularity both collapse. But perhaps that's exactly why black holes matter so much. Not just because they're dramatic or dangerous or mysterious, but because they sit at the crossroads of our knowledge. They're where our current understanding ends, and where the next great leap must begin. They ask questions we can't yet answer, and maybe never will. But we keep trying, because that's what science does, what humans do. We reach for the light, and sometimes we peer into the dark. Black holes are often thought of as endings, but perhaps they're more like punctuation marks, commas, not periods, pauses in the story, heavy with meaning, but not the final word, because while they may seem like cosmic erasers, there's something deeper, stranger, and altogether more unnerving going on beneath their event horizons, or maybe even on them. In the 1970s, a young physicist named Jacob Bekenstein had a wild idea. He proposed that black holes should have entropy, a measure of disorder or information. This was radical. Until then, black holes were thought to be simple, completely described by just three things: their mass, their charge, and their spin. Hairless, the physicist said. Black holes have no hair, meaning they don't keep the messy details of the matter they swallow, just the bare essentials. But Bekenstein argued that if a black hole hides information, then it must have entropy. And if it has entropy, it should also have temperature. And if it has temperature, it should radiate. That last part shocked almost everyone, because black holes by definition let nothing escape, not even light. But just a few years later, Stephen Hawking, working with quantum field theory and curved space-time, showed that Bekenstein was right. Black holes do radiate, slowly, subtly, through a process now known as Hawking radiation. Here's how it works, at least in theory. In the quantum vacuum near the event horizon, particles and antiparticles constantly pop into existence, then annihilate one another, but occasionally one particle falls into the black hole while the other escapes. To an outside observer, it looks like the black hole is emitting particles, losing mass. Over time, vast, unimaginable stretches of time, the black hole evaporates, shrinks, disappears. And that's where the question deepens. If a black hole vanishes, what happens to the information it swallowed? Does it leak out with the radiation? Is it encoded in subtle correlations between the particles? Or is it simply lost, deleted from the universe, leaving behind no record, no trace, no possibility of reconstruction? If the latter is true, it would mean something profound and troubling. It would mean the universe has holes in its memory. That information, once gone, cannot be recovered. That the past is not merely hidden, it is erased. And yet quantum mechanics resists that idea. In the quantum world, everything is reversible. Every process has a mirror image. If you know the present precisely, you can, in principle, work backward and reconstruct the past. The universe doesn't forget, but black holes might. This is the heart of the black hole information paradox. Not just a physics puzzle, but a philosophical one. A riddle about memory, time, and the permanence of being. Some physicists believe the solution lies in holography, the idea that all the information inside a black hole is actually stored on its surface, not inside the volume, but on the boundary. Like a cosmic library etched into the fabric of the event horizon. This led to the holographic principle, a theory that suggests the entire universe might be described, Not by the 3 dimensions we live in, but by information encoded on a 2-dimensional boundary far beyond what we can perceive. It sounds wild. It is wild. But mathematically, it holds together. In some models, a universe full of volume and depth might emerge from a flat page of quantum information. In this view, black holes don't delete the universe. They compress it. They fold reality in on itself like data in a zip file. Dense, cryptic, but still there. And yet, no one's quite sure if that metaphor holds beyond the math. After all, you can unzip a file. You can't exactly unzip a singularity. Other ideas have emerged. Maybe the information escapes slowly through subtle fluctuations in Hawking radiation. Maybe it's released in a final flash, when the black hole shrinks to a quantum dot and bounces back, like a cosmic cough, returning its secrets in one burst of revelation. Or maybe the information doesn't leave at all. Maybe it leaks into other dimensions, slipping sideways into realities we can't yet measure. A kind of cosmic laundering, gone from here but not from everywhere. And then, of course, there's the darker possibility. Maybe black holes do delete. Not carelessly, not cruelly, just naturally. Like a tree shedding leaves in winter, like a mind forgetting a dream. Maybe the universe forgets on purpose. Maybe it has to. After all, if information were never lost, if every particle, every collision, every whisper of motion persisted forever, the cosmos would grow unbearable, cluttered, overfull. Perhaps deletion is mercy. Perhaps black holes are not just destroyers, but editors. Still, the question lingers. Can black holes delete the universe? And the honest answer is, maybe. Not suddenly, not dramatically, but slowly, quietly, over trillions of years. Black holes are patient. After the last star has died, after the last galaxy has gone dark, black holes will remain, slowly evaporating into silence. If the theory of heat death is correct, then the universe's end will not be a bang, but a fade. A long, slow drift toward maximum entropy, where all energy is evenly spread, all structure erased, all distinction dissolved. Black holes may be the last active players in that story, the final places where things happen. They will swallow the last light, evaporate the last heat, and then nothing. A silent universe, a dark plane, a vast cold simplicity, or perhaps not. Perhaps at the end, in some way we can't yet imagine, black holes will give something back, a seed, a spark, a glitch in the nothing, the beginning of something new. Some cosmologists believe that black holes may be linked to the birth of new universes, that inside every event horizon, a new cosmos unfolds, disconnected from our own, expanding on its own clock with its own laws of physics. If that's true, then a black hole is not the end of a story. It's the beginning of one we'll never read. A doorway, not a deletion. An echo, not an absence. And what does it mean then to delete the universe? Maybe the question itself is incomplete. Maybe deletion and creation are part of the same act. Two sides of a cosmic coin, flipping endlessly in the dark. After all, even when a star dies, it gives birth to something new, a nebula, a black hole, a whisper of gravity that might one day gather dust into new stars. Maybe black holes are gardeners, pruning the cosmos, clearing space for the next bloom. And maybe, just maybe, the reason we can't stop thinking about them isn't fear, it's hope. Hope that even in the darkest places the story goes on. Hope that the universe, like us, forgets just enough to move forward, remembers just enough to matter, and deletes, not to end things, but to begin again. So when we ask if black holes can delete the universe, we're really asking something deeper. Can endings be beginnings? Can silence be a kind of song? Can what is lost still mean something? The answers, for now, live beyond the horizon. But we keep listening, and that, like the universe itself, is a beautiful, endless thing. Let's sink deeper now, not in fear, but in fascination. We've circled black holes from a distance, gazed at the shadows they cast and marvelled at the silence they keep. But if you're ready, let's drift in a little closer, gently, curiously, into the mechanism itself, into the edge of the abyss. Black holes may seem like sudden things, cataclysmic, devouring, destructive. But in truth, they begin quietly, with gravity doing what gravity always does, pulling inward. When a massive star exhausts its nuclear fuel, its inner furnace dies, and with that death, balance is lost. The pressure that once held gravity at bay fades like the